Hello, everybody. Good morning. Thank you for joining us. My name is David Moss here today with Nathan West, and we'll be talking about all things FARO. Primarily, we'll be talking about the brand new FARO Orbis recently announced. That'll be the main focus. But good morning, Nathan.
Good morning. Good morning. Hope everyone's doing well.
Yeah, excited to be here. So we'll be talking mainly about the Orbis. We'll be talking about the rest of the suite of FARO products as well, but we're going to make this a little shorter, probably be more scheduled for the 1 hour instead of the 2 hours we have down. But good morning, good afternoon, good evening to all of you across the world. And we'll get right into it. And anybody has any questions at any time, please feel free to put it at the chat at any time. We'll get to it here and we'll just keep on going. So again, FARO Orbis, brand new. We're looking forward to exciting. That'll be the majority of the presentation held by Nathan here. But for us as MGS, of course, authorized dealer for all things FARO. We've been talking about FARO, GeoSlam, Holo Builder, Sitescape, the works, some of the other solutions that we have that tailor around the FARO product line. So Recipe from Inertial Labs. So all sorts of vehicle mapping and aerial lidar. We have StoneX, great solution for all the survey, total station, all the control that goes along with the laser scanning. And then from the drone applications, you need something to fly it. So if you want to fly something like a GeoSlam Zip Horizon or of course one of the Recipes, we sure love our Whisper. And if you haven't seen already here on LinkedIn, mid next month, I believe it's on the 13th, we'll be talking about all things Whisper Sky Scout, a brand new drone, first of its kind. We're really looking forward to that. So but we'll keep on going. Again, if anybody has any questions throughout, please don't hesitate to ask. We'll get to them all one by one and keep on going. So also sneak peek, we'll be having a webinar here before the end of the year and a product announcement, but we have a really cool project coming out with GeoNet. We're looking really forward to telling you about, but that'll be on another day. So whole FARO suite, basically a whole reality capture toolkit. So it's not one tool is fit for every job. And FARO has a solution for everything these days. So from FARO themselves, and then they've been recently acquiring all these companies in the last couple of years. First with Holo Builder, and then Sitescape and GeoSlam. So we won't be going over into detail about GeoSlam in depth because of the FARO Orbis. We'll be talking all about mobile scanning and the power of GeoSlam and their technology, but the hardware has been covered from many others for many of the past years. So on there, but doing that. So exciting announcement just recently came out. Holo Builder, the whole platform is turning into FARO Sphere XG for next generation. Very exciting news. So you can take all your data from, of course, Holo Builder, but put it in with some focus data, some Sitescape data from other sources, and of course the new Orbis. So all the same things you can do if you weren't aware of Holo Builder, industry leader, 360 capture, again, complementary tool to the other things that you're using on the job site. So if you want to use any kind of construction progress, see how things going over time, get that 360 look, get the new video mode as well. Make sure to look that up. Really powerful tool. You can take it into any environment since it's just the speed of a 360 camera and you're just walking at a pace of a mobile scanner. You can cover a lot of ground. You can really get those updates real quick and in a cost-effective manner. So that's Holo Builder. And then Sitescape. So if you need a little more resolution of a detail and you happen to have one of the newer iPhones or iPads with LiDAR, fantastic solution. You can download this app straight from the App Store from Apple. Download their quick, beautiful visualizer. So if you need a little more detail of a room, but you don't necessarily need the quality of a scanner from the Orbis or the Focus, for an example, but need a little bit more precision on the visualization, that's where Sitescape comes in. There's even free options you can play around with. So if you have one today, you want to try it, Really recommend it. Super easy to use. Only takes about 10 seconds to figure it out. Just click and go. It's kind of like capturing a video. It's a cool new reality. So then, of course, the tried and true, the Focus, and then now on the Premium series. So same body, a little ruggedized, more form, but the new big king is, and of course, everything, all the scan times are improved, but with the new hybrid reality capture, what they're calling flash technology, where you put a Ricoh Theta Z1 1-inch 360 camera on top that has the ability to use that reality capture, get basically a 1/5, 3x X scan, all an incredible 28 seconds with color. So industry leading in that front. Um, Things are speeding up across that. You don't have to sacrifice quality anymore, but Focus is here. If you haven't seen the premium yet, especially with the flash, definitely would recommend that. 100% speed up your workflows, but from the main thing today. And to complement what the Orbis is coming out and a whole bunch of new things, there is a brand new version of Scene that is coming out early this month. So if you are a Scene user, make sure pay your maintenance renewal and get on the new version. There's a lot of exciting things that'll be covered by FARO. Contact us for more questions. But again, today is all about the Orbis. So I'll talk about that. And Nathan, we'll let you have the stage. We'll talk about your background, talk about what is SLAM, give the overview, and then we'll talk about what makes the Orbis such a special solution.
Yeah, the Orbis is super cool. So my background is working with surveyors and flying drones, doing photogrammetry is how I got into this world, this industry. And then I was hired on by GeoSlam. I got their nice little hat on, and I worked for them for about 2 years, just kind of helping people with different solutions. And now I'm working for MGS. So it's kind of fun how things bounce around a little bit. But because of that, because of my background with GeoSlam and photogrammetry, I have a pretty good grasp on point clouds and how to process them and the different meanings and all that. So I think I have a pretty good position to show all of you guys these really cool new tool called the Orbis. So it came about, like most things, there's an evolution to it. There's the GeoSlam Zeb Horizon is the most recent iteration, kind of the big brother or little brother to Orbis, and it's a combination of that Zeb Horizon along with the FARO Focus. So it can do these flash scans, the same thing that the FARO Focus can do, but in a mobile mapper kind of form factor. So it comes with a monopod, and you set it up on the monopod, and you hold it still for 15 seconds, and that's doing your flash scan. And you do that in between your regular mobile scanning, where you're just walking around, and whatever you see, it sees, and it is mapping. So it's kind of interesting to see how these two different technologies have converged into this one. It's really neat. So this explains it just a little bit more, where you have the mobile slam, the flash scan, and they combine into one with this Orbis. It's a really cool tool. So you can do large areas like a warehouse or something like that, doing the mobile slam. And whenever you get into an area where you need some higher detail, where you want to get down to this 2 millimeter precision, then you can do the flash scan. It's really handy being able to just walk this thing around and do high detail just wherever you feel is necessary. Super handy dandy. One of the coolest things I've seen in this sector. So GeoSlam is the company for SLAM because they've had 10 years of experience to throw a bunch of stuff at this SLAM to try and break it a bunch of different ways and then fix it after they do break it. So it's very robust. Just one of the biggest things that GeoSlam can offer is that highly refined SLAM. So SLAM is simultaneous localization and mapping, in case y'all didn't know. So that's using an IMU and a laser together to localize where the scanner is and map the area around it at the same time. So there are environmental presets with the Orbis. Whenever you bring it in to get processed, you can tell it that you were doing an outdoor, an indoor, that you had it mounted to a vehicle. You have all these different presets, so you can tell it how you scanned, the environment that you were in. So it optimizes that algorithm in the background so that you get really, really good, clean, accurate data, no matter what kind of environment or what type of scan that you were doing. So you can do local and global compensation. So local is what it sees, what the scanner, what the scan head sees in one instant, and global is the entire project together. So you can compensate one over the other and get really good, reliable outputs. And you can even scan control points so that you can place this on Earth. You can pretty much give it coordinates. And there's a few different ways of doing it. You can capture them manually by setting the unit down on top of it, or it can capture reflective targets. So there's a few different ways of getting this placed on Earth, and you have the option of allowing the point cloud that you've captured, all that data, to flex to meet those points, or you can keep the point cloud rigid and just have it lay on top of those points as a best fit. So if you have super, super accurate points, you might want to allow the point cloud to flex to them. But if you're just trying to get it on Earth, you can have like around a meter kind of wiggle room with the points that you're trying to set. Well, this SLAM is going to be way more accurate than that. So you can allow the point cloud to just set near those points. So you get a good place on Earth. So with this hybrid scanner, you can scan more in less time with higher precision. It's really, really cool that you can just walk around, scan huge areas, and whenever you need to get that high precision, just hit a button, hold it real still, and you've got high precision. It's really cool. So it pretty much replaces two devices. You're taking two devices, putting it in one, like an entry-level terrestrial laser scanner that's tripod-based. You're combining that with a mobile scanner. There's a few different out on the market. GeoSlam, we like to think, is the best. And so it's the GeoSlam combined with an entry-level total terrestrial laser scanner. It's really neat. And because of this, because you're combining the mobile mapping with the terrestrial, there's almost no registering the data. Like 90% of the time, you're not registering anything because it's automatically registering as you're moving around, thanks to that mobile SLAM mapping. Really neat, really fast, and really accurate at the same time. Like people have been wanting that accuracy with the speed, and we finally have it. It's so neat. So here it is kind of broken down. You have the scanner origin marks with the FARO label, the LiDAR puck that spins, it's out there on front. It's a Hesai XT32. You're getting 640,000 points a second with that. You're getting 360 by 290, and it's because it's sitting there spinning, so you're getting everything around you is being mapped, except for the person that's holding it right behind it. You can remove the handle, and whenever you remove the handle, you can attach a monopod. You can attach the unit to different mounts, like a car mount, a cradle. It's really nice. And then you have your camera on top that's getting 8 megapixels at a time. It's taking that every once a second. You're getting a 360 photo out of that camera that sits on top. So that's all the things broken down. And you also have, if you see at the very bottom corners, that's your data collector. This is plugged into a data collector while you're scanning so that that data collector is providing power and it's capturing all the data. And the results are just really, really super nice. Being able to see that painted mural there, it's very clear, very crisp. You can capture huge amounts of data. This entire work site you can capture in just a few minutes just by walking around it. And whenever you get into these rooms, like pipe rooms, where you need that higher level of detail, you can do the flash scan and you can pick out the different types of pipes, the different sizing of the pipes. It's incredible that you can both get this huge area in a small amount of time, as well as get this high level of detail in those areas that you need it. If you're just doing floor plans, we have that kind of option. You can make it really, really simple or really, really complex, depending on whatever kind of data that you're trying to capture. Then you can capture it and it will look really good and be highly accurate.
We got our first question. Um,
Can you adjust trajectory in post-processing? I'm not sure exactly what that means.
I would
Whenever you
assume that would mean, like tying in the control or using that, or if you want to talk
Okay.
about tying in with the X on the plate and about the Zeb locate, I think that would probably answer that. But if you want to go into
Yeah.
both of those,
Yeah. So if I can find a good photo of it, here we go. So if you see where the handle is on the left-hand side here, there's a plate on the bottom. At the front of that plate, there's a little crosshair, and you can set the unit down on top of known points. You press a button, it'll capture that, and it'll be a feature that you can then assign XYZ values to in the post-processing. One method of doing it, you can use reflective targets that are setting on top of known points. Again, it'll see those reflective targets, note it as a feature point that you can then assign XYZ to. And another way to adjust trajectory is we have a locate system where you attach this to a backpack that's tied together with a GNSS receiver. You set that receiver to 1 hertz so that once every second it's going to ping the satellites to know where it is, and you'll put in post processing, associate that data that you collected with the GNSS. You'll tie that to the trajectory that this captured as you're walking around. So whenever you tie those two together, it moves that trajectory to a place on Earth, so it's located. So there's a few different methods. Some are easier than others, depends on the project that you're doing.
and one other thing as well too, when you're using all the adjust to control and just a lot of the parameters in the Connect software, Nathan, we'll talk about here in a bit, is that you could change it to an open loop scan for both of those solutions, tie in with the control, or just do the best you can where it knows that it's a open loop scan as well. But there's a lot of options. If you have any other follow up with that, we're happy to answer it. We got a viewer all the way from Uganda. It's pretty cool. All the way around the world. So keep going, Nathan.
Yeah. So those are examples of the data that you can capture with this and what it looks like. It's highly accurate, very visual. You can capture anywhere with it. And here's actually an example of the locate system, the backpack that you see on the lower right-hand side. There's a guy with some skis and a lady with a backpack. That's our locate system that you see there. But this kind of showcases that this can be taken anywhere with any kind of travel method, skiing, cars, backpack, just walking it around. You can capture highly accurate data very quickly, very easily. So it has so many different applications from volcanoes, dockyards, what do you call them? Piles, volumetric piles whenever you're mining. Um, Even after like a forest fire, you can go out and you can scan it to see exactly how much devastation's been there. If there's a lot of trees that are left, that it's going to be a viable forest again. There's just so many applications because it's such a versatile tool. Even more so now that we have this Orbis with the highly accurate flash scans that it's capable of, and of course the upgraded Hisai puck. So here's an example of how much money this can save just in the time savings. So if you have a 1,500 square meter project size, here's a comparison of using the Focus with its flash scanning compared to the Orbis. It's like a tenth of the time that you spend in the field. It's incredible. And of course, the time saved equates to money saved. So if you purchase one of these, you can almost assuredly save yourself money just by saving yourself so much time. You need the data. So you go out there and you capture it. You have to choose the best capture method for the project. And I would say that 90% of the time, the Orbis is going to be your best bet just for time savings. It's highly accurate and you can trust the data. And it's almost doubly so for a large site scan. So if you go from 1,500 square meters to 10,000 square meters, a really, really large project site, it compounds with the time savings because you can go across the site so much faster, still capturing the accurate data. Just the time savings, the money savings is incredible whenever you actually bring this onto the site.
So what is a flash scan for everybody, Nathan? What's kind of the difference between a regular mobile scan, a regular terrestrial scan, and the flash technology?
So the flash technology speeds up a terrestrial scan. If you have a tripod-based laser scanner and you do a flash scan, it's just incredibly fast while keeping that high level of detail, that high precision. And whenever you're doing a regular mobile scan, it's really, really fast, but it's not very accurate. So again, we bring in this flash, so you're holding it stationary and it's taking a very quick 15-second scan where it's capturing just a huge amount of data. And because it's being held still, it can keep that high accuracy that you get with a tripod based. So a flash scan is essentially a FARO um, invention pretty much where they do just a really quick scan from a fixed position. Pretty cool technology. Pretty cool technology, and that they're bringing it that they're bringing that flash scan into the mobile scanning with the SLAM. That combination of flash and SLAM is just it's going to be a game changer for a lot of people. Very exciting. So the flash comes with the Orbis. On every Orbis, there is no subscription that's needed because it's just an integrated part of the product. Um, yeah, it does incredible things with the visualization, the density of the data and the accuracy of the data is just incredible. So we keep harping on this because it's the biggest thing with this product and pretty much the biggest thing in this industry is combining that terrestrial scan with a mobile SLAM scan. Because it used to, you'd have to make a choice. Do you want the exceptional precision or do you want the exceptional scan time? Do you want the speed or do you want the precision? Always been a give and a take. You couldn't have both, but now you can. So you used to have to set up a tripod multiple times in a room because you have to get around objects. You don't want any dead spaces.
And
So it'd take a long time.
it's important to note too that this is the workflow with the world's fastest terrestrial scanner at 28 seconds. If you have a current terrestrial scanner, say your scan time's a minute and a half, 2 minutes, multiply it by 3 or 4 times on the time to get that real number.
Yeah, it's very true. Thank you for pointing that out. So this is definitely done with Flash, and even with Flash, it's super fast scanning. It takes 25 minutes to do 21, where you set up the tripod and you do 21 different scans, and you have to register all of them together. Well, luckily with Flash, they do self-register for the most part. But even with all of that, even with Flash, even with the self-registration, it still takes 25 minutes to move this thing around and do all the different scannings. And so with SLAM, you can walk around and this is without using any flash. This is just doing a regular SLAM scan. You can do that same amount where it took you 25 minutes. You're now doing it in 2.5 minutes. It's very, very quick, but you're losing some of that precision due to the speed that you're moving around. So when you combine the SLAM with the flash, you get just you get the precision, you get the scan times, the registration's automatic. It's so much faster while keeping that precision. You don't have to make the decision anymore between speed and accuracy. You can have both. It's pretty incredible. So it does increase it from 2.5 minutes to 5.5, but that's still so much faster than 25 minutes. In 5.5 minutes, you can capture an entire floor, an entire house, an entire office building, or a floor of an office building, I should say, in 5.5 minutes. It's just super fast and keeping that accuracy. It's just incredible.
So we have another question, Nathan.
Hmm. With
that we might
underground utilities, yeah, if you can see it, it'll scan it. It doesn't do any kind of ground penetrating. There's no multiple returns necessarily. It goes by line of sight. So if you can get it into an underground vault, if your underground utilities are in an open vault underground, then this can be lowered down using a pole down into that vault, and it'll scan it. So it does need, a little bit of room. It is kind of a larger object, the scanner itself. But if you can get that down into an underground area that you're trying to capture, it'll capture it. But again, it does work by line of sight. There's no ground penetration or anything like that. But if you can see it, if you can get it down there to look at it, it'll scan it. You'll have highly accurate measurements.
And there's a lot of people using this, dropping it down, popping it in a manhole really fast, dropping it down a mine shaft, just doing it in the mines with a bunch of pipes, utilities, cables all around. So yeah, there's a lot of versatility on that, but it does in fact does not penetrate the surface of anything.
Yeah, I want to be clear about that. It is line of sight. So yeah, this FARO Orbis combines that slam and the flash to just be super accurate, super fast at the same time. So here's a comparison of the older version, the Zeb Horizon. The GeoSlam Zeb Horizon would capture this, what you see on the left, and it's accurate, but it's not that accurate. It's not very pretty. It's kind of fuzzy that you can see on those pipes. Where whenever you compare it to the Orbis Flash, it's almost like a photo. It's so crisp, clean, dense. Because as you can see, there's kind of spottiness on the left-hand side, where on the right-hand side it looks very solid. It's just incredible, the difference. And it's the upgraded puck, the upgraded IMU, and this flash capability where you hold it still for 15 seconds, it does a scan, and you get this incredible output. It's just so amazing. Again, here you can see the crispness of the one on the right-hand side. And on the left-hand side, you can see that it's there, but it's not, you can't tell exactly what's above it. You can't see the solidness of these objects. It looks fuzzy. Where on the right-hand side, you can see that there's an elevator symbol above the one. You can really see like the pingers that it's holding up that ductwork or that piping. It's so much cleaner and so much nicer. It's just crazy. And so whenever you're out and capturing, you use an app called Stream. And so you can see live as you're capturing what you're capturing as you're going around. Makes it pretty nice and handy. So if you miss a spot, because again, it's line of sight. So if you miss a spot, you can see that there's a gap there. So you can go back, let it see whatever is missing, and you know that you have a full capture.
And it's a nice thing to note on this is that it's also the same Stream app that you use for your FARO Focus. So everything's all in one place, all one, Sphere XG login. It's all in there. You can integrate and go back and forth real fast. So we have another question. 2 minimum scan distance. I believe it's 0.5 meter. Mac, you know that's what it was on the Horizon. I assume that's on the same.
Yeah,
Anything
and
to add?
that's a pretty common thing for LiDAR scanners in general, because the speed of the return, whenever that light hits and bounces back, it's just so fast that a lot of sensors is just too quick to get any kind of accurate measurement out of that. So that's kind of a basic scanner minimum. I know there are some that say that they can go down to 0, but if you want to trust the data, I'd say 0.5 meter. Yeah, this app is really handy dandy that you can switch back and forth between the different devices that you're using, as long as it's a FARO device. So you get the real-time visualization. You can capture targets and control points, and it also allows you to do that flash scan. So you bring this app up, you're moving around, you see what's going on, and you say, "Oh, I need to capture high detail in this area." You hit a button, you hold it real still, and the button that you hit is in this app. And it's the same thing for whenever you're trying to place this on Earth, whenever you're trying to adjust the trajectory. Whenever you set it down and you have that crosshair that's on the handle right over the known point, you hit a button in this app and it will capture that. This is the app that you use for different types of capture and for the quality control visualization. Really nice app, really handy dandy, and that you can have it sit on the back of the scanner unit, just right there for you to see as you're scanning, hands free. Pretty cool. So whenever you're done, you can upload this to the Sphere XG, kind of what David was talking about at the very beginning of this. The Hollow Builder is pretty much what the Sphere XG is now. Yeah, so you can upload as you finish your scan to the cloud, and you can share it very easily. You can get it processed in the cloud. That's an option. It's not necessarily what you have to do, but it is a pretty nice option that you can just bounce it to the cloud as soon as you finish your scan.
So yeah, so you have the choice now. You can stay at the local with the FARO Connect software, but with that and the new SLAM iteration that comes out with the Orbis release for all the GeoSLAM lineup, have the choice of you can use the Stream app and upload right from the job site straight into Sphere XG. Do that as long as you have cell connection, and then by the time you get back in the office, you already have process point cloud. Or you can, or you can use the same local, connection that you can do where you can either, transfer from Ethernet or from USB the data onto your computer. So there's a lot of versatility. You can buy, perpetual options of these or subscription year to year. So there's a lot of choices from a lot of things that are versatile kind for FARO. So in the marketplace.
Yeah, FARO's done a really good job keeping everything nice and flexible because not everyone's doing the same type of project, same size, same frequency. So they kept it really flexible. So like he said, you can do the perpetual licensing, you can do it year by year. You can process everything up in the cloud, which is going to cost more, or you can just keep it all localized and do it all on your own computer. So it's good for Department of Defense and that type of thing. So it's nice that FARO's kept that flexibility for everybody.
And there's one more important thing to note with that none of the other cloud-based solutions have is that when you purchase the cloud, it's all free and unlimited. There's no, pay as you scan. So there is a, limited storage. I believe it's 500 gigs to start, or if you want to store projects on there, but just to process it in the field is free and unlimited as long as you have a subscription. So it's just the one, couple thousand fee for the year, and you're off to the races with a lot of fun. So
That is a very good point because sometimes you do a project and it comes back where something has slipped, there's some kind of error in the cloud, but our Connect software allows you to reprocess and you can correct for some of that. And so being able to process on the cloud and to repeatedly reprocess different projects is a lifesaver for a lot of different people, especially that it's free and you can have unlimited processing. It's very necessary for some of the more complex projects that a lot of our customers will have. So here's our Connect. You see up in the right-hand corner, the top right-hand corner, this is Connect, FARO Connect. And so with a single click, you can import all your data sets that are captured within a project. So you have multiple scans. You can drop all those scans all at once into this piece of software. And you tell it if you want it cleaned and colorized or not. And you tell it the capture environment that you were in. If you were indoors, if you were in a forest, if you were in a really confined space. You can tell it all of that right off the very beginning, right off the bat. You drop everything in, you tell it exactly how you want it processed, and it queues them all up and it starts the process pretty quickly. So you can filter the data, colorize it, do the reference point extraction so that you're placing this on Earth, and you can do the flash scans. You can pull out just the flash scans if you wanted. So you have all of the mobile scanning. That's a little bit of the rougher data. It's only down to 5 millimeter precision. If you want to keep only the scans that had the 2 millimeter precision because you just want only the really, really tight data, you can. You have that option. You can pull out just the flash scans that are already registered because they're registered using the mobile scanning. They're already registered to each other, and you can pull those out just to keep that really nice data. Again, FARO made it really flexible for everyone. It's pretty nice, depending on the different projects you have. Maybe you do, maybe you don't. You have that option. So we'll go a little bit through the workflows and the softwares. So the online workflow is that you capture the data, that's the acquisition. You use Wi-Fi to send it up to Sphere XG, process it up in the cloud, and you can share and import it in the cloud as well. And we have the offline that we mentioned, where you use Wi-Fi, a direct cable connection, or you use a USB stick as the transfer to take that acquired data, put it into your laptop, your computer, you process it there on your computer, and you can do registration and analysis in FARO Scene, or you can keep it on Connect and you can do some of the registration analysis just straight into it.
So we got another nice comment from Ron that we got to meet at the show a couple weeks back, but I appreciate the feedback, Rob. Nice to see you
Yeah.
here.
So you have your options here, using Connect, using Scene to register, or you can use the Sphere XG that's up in the cloud solutions. But having that desktop package or the cloud solution is pretty nice. And Connect will take the SLAM data, pretty much just the SLAM data, the Orbis data, and convert that into a cleaned, colorized, and geolocated point cloud if that's what you need. That's what Connect can do. And Scene is for taking the TLS data, the terrestrial laser scanner data, and combining that with the Orbis Flash, if that's how you're doing it. Scene is a pretty good option for doing that, combining and registering larger projects, multiple different capture methods, bring those into Scene. If you're doing it all with the Orbis, you can just use Connect. So again, flexibility depending on the tools you're using, the data that you're wanting, the projects that you're doing. They can be widely varied. So they have all these different options to kind of approach that.
We got some other questions about Connect filtering. Can you talk about the transient and the noise filters and all the things that you can do there?
Yeah, there's a handful of different filtering tools that Connect offers. One of them is a transient, so it's moving objects. It has a filter that'll take those out. It pretty much breaks the scene down into cubes. How long was an object in that cube? If it's a stationary object, it'll be in there for quite a few seconds as you're moving by. If it's a moving object, it'll be in and out of that cube of space pretty quickly. So like you're in a busy office building, you're scanning a busy street or something like that. You can get rid of the moving vehicles, the moving people, using one of these filters that we call the transient filter. And then they have a noise filter that pretty much takes a flat surface. Is whenever you use a noise filters, whenever you're doing buildings, places that have nice planar surfaces like ceilings, floors, walls. The noise filter will take into account that it's on a plane, and it'll count how many neighbors it has within a certain distance. And if it doesn't have enough neighbors within that set distance, it'll kick it because it must not be on a surface if it doesn't have a lot of neighbors. Let me think of the other filters. I can't think of them off the top of my head, but
You get the range filter.
the range, the outlier. There's an outlier filter that again takes into neighbors. If it doesn't have a lot of neighbors, then it must be a point out by itself. It'll kick those. You have a range filter. So if you're doing an indoor area, you don't need the full 120-meter range that the Orbis has. So you can kind of kick that back down, say I only need 30 meters of range because it's 100 feet. That's a really large room. You're still able to capture all that data, but you're not going to get a lot of noise on the outskirts. You're not going to get too many reflections and stuff because normally those reflections will say it's something that's over 100 meters away or a substantial difference in distance than what everything else is. So you can kind of use those range filters to cut out some of that noise or unwanted data as well. So there are a few different filters that are offered to make it pretty easy to clean up your point cloud so that whenever you do bring it into whatever modeling software or whatever measuring software, it'll be nice and clean and you can see what you need and it's just the data that you want. Pretty handy, some of those filters. So yeah, this FARO stream gives you that real-time feedback. You capture reference points. You can transition between using the or the Orbis. So you switch back and forth. Say you're doing something that has like a really nice or really complex mechanical control room. It's just pipes and things everywhere. We can bring your focus in there, capture that super high detail with that terrestrial laser scanner, and tie it right in using the FARO Stream app, just switching back and forth, tying everything together. Makes it pretty easy to do really complex things. Oh, it does look like we have another question. So how does it merge data collected in two different sessions? Example given, before and after lunch. So you would use the Connect software to take two different scans and merge them together, or scene. Um, so it doesn't necessarily do it in the Stream app, like right away, but in post-processing, you can merge two different scans into one scan, and you can do that using targets. You can do that by using overlapping scans. So you have like an area that has a lot of overlap, that has features in it you can use to align it, or you can use the GNSS or GPS station, where you capture different points. You assign XYZ value for whatever coordinate plane. And as long as it shares a coordinate plane with the same project from later in the day or whatever, then you can tie those together fairly easily. So there's a few different methods of doing this. Again, depending on the project, depending on the tools used, you have some options.
You want to talk about just scan times as well, about how long you can go in the slam mode and kind of the suggestions with that?
Yeah, the suggestion is from the company that you do about a 20-25 minute scan time maximum. That is not a hard cutoff though. They say to keep it around 20-25 so that you have small, nice, easy chunks for your laptop to chew through, so that if something does slip, something does go wrong, it's easy to go back out and do a 25-minute scan as opposed to like a 2-hour scan. Also, it keeps your loops a bit smaller. Like whenever you're doing survey loops, if you go way out and you come way back, you can introduce a lot of drift. The further out you go, the more error you can introduce. It's kind of the same thought process whenever you're keeping your scans to about 20-25 minutes. You're just keeping those loops a little bit smaller. It can adjust for the drift. It can adjust for the error a lot easier than if you're doing a massive scan. So it's not a hard cutoff at 20-25 minutes. We've had customers that do like an hour long, and their data came back looking pretty good. But again, just for complexity's sake, for keeping everything nice and simple, for data management's sake, keep it around 20-25 minutes. But if you're walking or even mounted on a car, you can cover a lot of distance in 20-25 minutes. So it sounds like it's a pretty like, oh man, only 20 minutes. But you're actually getting a lot of data. And as I mentioned with the merging of two different scans, so you're doing one before lunch, one after lunch, just like that. You use these different points, you use overlapping data. You scan in the same area that's shared, and it's fairly easy to take a 20-minute scan and another 20-minute scan and combine them, even multiples. If you're doing a whole office building, 70 stories, each floor is probably going to be a scan, maybe 2 scans per each floor. And so you just start combining those together and you just stack them up, just like it is in the office building. And, you know, you have all of the data that you want in a matter of a few different scans. So it's not too hard to merge these together, and it gives you the ability to do huge sites if you needed to. So again, talking about the Stream app, you see its little symbol up there in the top right-hand corner. It's a unified app. You can manage all that project data. You can group the scans together, kind of like what we're talking about whenever we're trying to merge them. You can at least have them grouped, so whenever you get back to the office, you have really good data accessibility. It's going to be right there. They're already grouped together. It'll be easy to put them together. You have the real-time data visualization to ensure that you are getting all of the data. You have complete data, and that if it did slip, if there was error, you see it right in front of you as you're scanning that it's slipping, that you are introducing error. And so you can either slow down, you can go back. There are different things that you can do to really help out the SLAM to fix any kind of error that's being introduced. So having that real-time feedback gives you that opportunity to go back and fix it, to make those corrections. And of course, with our Stream app, it has a direct sync to the Sphere XG. so that you can send it straight to the cloud. As soon as you finish that scan, it's up there and processing. You're on to your next scan. It's pretty nice, really nice. Time saving on top of time saving. So the FARO stream, again, with the visualization, you're reducing your rework, you're optimizing your efficiency. Your data organization is going to be really, really nice because you can group those scans together. You can send it to the cloud so that's processing as you're going. So the data is almost organizes itself. Just take a couple of key steps and it's smooth sailing with that data. And the capture versatility that you're able to go back and forth between the Orbis and the oh man, it just slipped my mind. The other FARO product, the terrestrial laser scanner that you can pop back and forth between those two is really, really handy. You're in the one app, keeping all of your data together, grouping them as you do your scans. It just streamlines the whole capture process. We'll dive a little bit more into Connect here. So it's called FARO Connect. It takes all of the Orbis mobile data, the Orbis flash scans, and it ties them all together and it gives you a visualization of that so that you can see which filters that you need to run. You can see any kind of slip so that you can reprocess the SLAM. You can adjust any of the fine tuning controls to make sure that you have good, clean data. Really nice product, piece of software. So you just load your projects in, you open them up, and you're rolling right along. So again, you can process, clean, and colorize with the flash scans without the requirement for registration, which is huge because it's automatically registering those flash scans together using that SLAM data. You have your filters and classifiers so you can get rid of any of the points that you don't need. It incorporates the 360 panoramic images because if you remember on the Orbis, there's a camera sitting on top of it that's taking a 360 photo every second. So it creates like a Google Maps kind of street view where you can click from photo to photo so that you can do more quality assurance, more quality control to make sure that whatever's being modeled, whatever's being captured is apparent and known. So you're using those photos to just verify. And you can georeference the point clouds using Connect, again, by using the manual capture where you set it down on top of a point, the reflective capture, or the GNSS capture. There's different ways to georeference your point cloud. And you can use Connect to sync your data with the FARO Sphere XG, which is pretty much the cloud-based way to show, share, and do more quality control in the cloud. So it makes it really easy to share with your clients, share with your customers. They don't have to download a whole bunch of different software. You just send them a browser link and it opens up in their browser and they can view what's going on. It's pretty handy. So with Connect, you get streamlined workflow, reliable data, share and collaborate, really fast processing. And it's easy to use for new users. Like the training is very, very simple. There's not a million different buttons. It does pretty much a really simple thing of taking that captured data, converting it into a point cloud, cleaning it, colorizing it, and making it available. So it pretty much just creates the point cloud that you captured. It's pretty simple. Yeah, there's some filters, there's some buttons to it, but it's really, really simple piece of software, powerful and simple. So with the XG, with the Sphere XG, you can do the cloud processing where you just upload the data and it'll start processing it up in the cloud. So you're saving time. You can just keep scanning, or you can travel back to the office and it's processing up on the cloud as you're traveling, as you're doing something else. So whenever you get back to the office, it's all there. You have your point cloud, you have your data sitting there for you so that you can start work right away. So essentially, you load up your projects, you can pop them open, you can view what's going on. You have your captured 360 photos or those blue dots there. So it's all the data is there for you to view, for you to manipulate, to see what's going on, to share. Really, really handy piece of software as well. So you can also measure in this, which is pretty nice. So you can actually do like real work. You're not just doing visualizations, you're not just doing quality control. You can do measurements. You can pull real data out of it on the fly. So you send it to your customer and they're like, well, is this opening big enough for me to put this piece of equipment through that I just ordered? He can just do the measurement right there through the cloud. It's pretty quick, pretty handy. So you'd use the Orbis cloud processing to save time while data is processed. You can use the cloud for the processing. So maybe you don't have just a screaming laptop to do all this processing on. We'll just send it up to the cloud. It gets processed up there. So you don't need that heavy duty, super expensive processing unit. You can just send it up. It makes it pretty easy. And there's also the data management because it's all held in the cloud. It's a little bit easier, lighter on your IT team or whoever's responsible for the data management. It just kind of makes it smoother, easier, more seamless. They're not having to do quite as much. And this leads us to the use cases. Again, it's super versatile. Just the hardware itself is super versatile. The software makes it even more versatile. You can do large projects with low levels of detail, scan to BIM, which is building information modeling. So if you're trying to model a building, you're trying to model a space, this is a perfect product for that. Construction progress monitoring, because of the speed, you're just walking through the construction project. Whatever you see, it sees. So you just show it. Just walk through and show it the whole project. And before you know it, it's all captured. It takes you no time at all. So you can do this daily, you can do this weekly, you can do this monthly. You can do it while the site is active. You can do it while the site's dead. It doesn't matter because you have those different filters because it's mobile and versatile. It's great for construction progress monitoring. If you only have a limited time on site for whatever reason, because of the workers, because of just the environment itself, because of our capture time, because we're so quick, we're great for that. You only have a little bit of time, cool. All I need to do is just walk through it once real fast. I have all the data that I need. And because of the range of it, it has a 120-meter range, you can do large outdoor areas fairly easily. um, just huge range. You're reaching out like 350 feet, 400 feet, and you can capture everything. You can mount it on a car. You can mount it on a golf cart. We have all these different options for capturing large areas.
So I think it's important to know too, maybe you can talk more about that, specifically on GeoSlam's just SLAM algorithm with all these different applications that, doesn't require the use of visual SLAM. You can be in a pitch black mind, just with your headlamp on and still get the same accurate results.
Yeah, yeah. And that kind of falls back on the software and the different sliders and variables that you get whenever you're trying to process the SLAM. Um, you can really customize it for really complex environments, but they have those presets. Like where if you're in a forest, if you're in an enclosed environment, if you're indoors, if you're outdoors, you can tell it that kind of environment. So it's reaching for smaller features, larger features. It's reaching further out. It's trying to stay closer in. You have a lot of different options to kind of flex to meet these different needs of these different environments. Like David said, if you're in pitch black, that's fine. You can send this down into a pitch black manhole. It'll still scan it, have the high accuracy, have all the data collected, even though it's pitch black. It can be,
And it can be at any angle too. You could do the whole scan upside down or put it there. You don't have to hold it in a certain way or
yeah.
be in orientation. That's a nice separating factor as well.
And that kind of speaks to Geoscience history. They got their start in mining. And down in mines, there's no easily to grab georeferencing points. All of their control points are in the ceiling because that keeps it out of the way of vehicles, of ore, or anything like that. So to be able to capture those points, it had to be able to turn upside down, capture the point, be turned right side up without breaking the slam, without losing where it is, without gaining too much error. So from the very beginning, it's had to be turned upside down, it's had to be turned sideways. So it's great at these different orientations that you might need for capturing something like a manhole. You're walking towards it right side up, you turn it upside down and down into it. Well, that's a pretty complex movement for a SLAM algorithm to be turned upside down. But this one, it loves it. It's totally fine being turned upside down, turned sideways, placed in the dark. We do above ceilings captures with a lot of people because there's drop ceiling in offices, hospitals, and stuff. There's a lot of pipework up there that they need to capture. They need to know where it is, where it's going, if they have room for more, if they need to take any out. There's a lot of different reasons that you might want to go into an environment that's completely black like that. We do fantastic at that, just fantastic. The GeoSlam algorithm, the SLAM algorithm running in the background is just magnificent. They've thrown so much at it over the past 10 years and overcome all those obstacles just to make yet again another wonderful product in this Orbis that it can reach out further, capture more points, capture finer detail is just again another step down this road of being really really awesome at capturing geospatial data. It's pretty cool. We do have a little bit of limitations on the amount of detail and the range. Like we cannot do an entire outside facade of a high rise, um, a skyscraper. We can only reach 400 feet. So that's what you get. You can't do just huge long range scans with it. And you can't do extremely high detail, high fidelity scans either. We only go down to 2 millimeter. If you're trying to find a 1 millimeter crack, we may or may not pick that up. We're only down to two. So there are some limitations. It's not just the Swiss Army knife that's going to solve everything. It's the Swiss Army knife that'll open letters and do stuff like that, but you're not going to clean a deer or something like that with a Swiss Army knife. It's a tool for the job type of thing. It does a lot. It's very flexible, very capable, very versatile, but it doesn't do everything. So we don't want to give that kind of impression. It does have its limitations, but it's still very, very capable. So in the construction and engineering architecture industry, there's a lot of different applications. I think we sell a lot into this. Um, so it's again with the as-built capture and modeling, installation and placement accuracy. So is this big enough? Is this opening big enough to fit the equipment through? Was it installed exactly where it was supposed to be installed? Um, yeah, it's very useful for all those type of things. Even something as simple as creating floor plans, because you need accurate floor plans so that you can accurately describe the square footage of the warehouse, the office building, the home. You can do floor plans very, very quickly, very, very accurately. It's great for all these different applications. In the more general geospatial world, doing infrastructure, culvert mapping, roadway mapping. It's great for that. You just strap it on a car, strap it on a cart, run it down the road, run it down the power lines. We have people putting it on an ATV. It can take those big bumps, those jolts, not super big ones, but we have people mounting it on an AV and riding some fairly rough terrain and capturing good data, usable data for what they're needing. And it's just super, super flexible, has all these different applications in many different kind of industries, including public service. So with the critical infrastructure documentation, we have a few different people that are doing skulls so that if there's any kind of event, any kind of 911 call for an office building, a school, a campus, we have the data to just hand over to them, like immediately, as soon as they need it, oh, something's going on. Here's all the different rooms. Here's how it's laid out. Here's the different access and egress points. Very, very useful in a lot of different applications. And so we do have some competition. There's a few different people that are trying to use SLAM, trying to recreate some of what we do with this Orbis, but no one has it completely tied together. Here's kind of a quick little overview that shows you, are you using static scanning or are you using SLAM scanning? No one else has combined those two. We're the only one that combines the SLAM with the static scanning to get those high detail points while keeping up the speed. And so we're not perfect. Again, we're not perfect. Our camera is only 8 megapixels, so you're not going to get the greatest photos out of it. We are fairly expensive, but there's a reason we're expensive because we do really, really good work. And there's optional registration, where others you have to register it, especially if it's a terrestrial one. You have to register it for those things to be tied together, for those different scans to all come together. You have to register them. Well, with this one, they are automatically done. So even whenever you're only looking at the terrestrial side, There's great big wins where we are substantially better using the Orbis than even the Focus Premium because of the registration. So there's a few different things that just make it really stand out. Not just that it combines the two different things, but it combines them very well. So it's not just like an okay at one and okay at the other. It's actually really good at both the SLAM and the static scanning. So here's just with our competition with Naviz, it's kind of bigger and bulkier. It has beautiful point clouds. The Leica Hexagon, the BLK to go, it's really light, really nice, simple form factor, but it's only handheld. It only gets so many points. It's only so accurate, but it looks really good and it's very easy to use. So again, each of these have their positive and negatives. Like our camera, again, is not the greatest. Our price is not the greatest, but we're super fast, super accurate, and very dense point clouds. So it's a give and a take with everything.
And by far the most versatile with the fact of being able to do the static. You know, you can, put it on the pole, pop it through the ceiling. You can tie it in with the
And
GNSS in real time. All the accessories, put it on a vehicle. That is a lot
mhm,
of the separating factor as well.
yeah, the versatility, very, very much so. That you can mount it onto anything. You can turn it upside down, turn it sideways. You can jostle it around. I know that the Naviz and the Hexagon, they really don't like to be bounced around too much. Their SLAM will break fairly easily compared to the FARO Orbis. And again, not to talk trash. I know they are competitors, but it's just they're better than us in some ways, and we're better than them in a few more ways, I'd like to say. But it's tool for the job type of thing. Tool for the job. So even in the terrestrial laser scanner, because the last slide was the SLAM comparison, here's the terrestrial laser scanner hardware comparison table. And again, we're not green all the way down, but we do have a lot of green, and we're very flexible, very versatile. We can be used on a lot of different projects, a lot of different types of projects. Where these other ones, they're very specific for the type of project that they're going to be used for, because they're almost made to be that specific, to be really, really good at doing this one thing. Where the Ferro Orbis is just so versatile, so flexible. It can do so much. And so that brings us to the end of my presentation. If there are any more questions, I'd be happy to
So
answer
we'd
them.
be happy to answer any more questions. If you want to reach out to us individually, we're happy to help. Of course, happy to do your free on-site demonstration at any time. But we'll let it sit here for a minute or two for questions. But if that's not it, thanks for joining,
Yeah, that,
Nathan. Thank you all for joining. But again, FARO
yeah,
has the reality capture tools from 360 image capture and the whole builder platform, now Sphere XG, to Sitescape quick visualizations just using your iPhone or iPad, to the mobile side and the versatility of there what they have, and then of course the tried and true, the highest accuracy, you get the most results in the focus lineup. So looks like we have a question that has come up. Nice to see you again, George. Uh, so no, none of these, nothing I know on the marketplace can combine any kind of other other imagery. You could use other things and tie them into a different platform, but there's nothing I know of that's a commonplace tool from any company where you could just bring your own camera and colorize it that way. So, um, any thoughts on that, Nathan?
no, I agree. I think I've heard of a way that you can combine like different photos into this, but it's not easily. Like you just might as well say no, pretty much.
So, a couple nice presentations. Appreciate it,
Yeah,
Matt and John. Thank you guys both for coming. If we have any other questions, again, please feel
man.
free to.
I wanted to reiterate the coming out and doing demonstrations. That's one of my favorite things to do with this is to go out and do demonstrations, see what kind of projects people are doing, what they're wanting to do with these tools. because again, it's so versatile. You never know what someone's going to come up with, and going out and doing those demos is one of my favorite things to do.
Perfect. Well, thank you, everybody. Again, we appreciate your time. And again, next month on the 13th, we'll be talking about all things Whisper and their brand new Sky Scout drone, first of its kind, and we'll be looking forward to that. So make sure to join. Again, MGS, me, myself, Nathan, and the whole team, all things reality capture, from terrestrial laser scanning, as we talked about, mobile, of course, aerial LiDAR, and then all the accessories and drones and everything to tie it in to get a great accurate solution. And we have multiple software options as well. So keep us in mind. We're happy to come out on site again, like Nathan mentioned. Appreciate it. You can also find on FARO's website, or you can reach out to us. Of course, there's brochures for everything we talked about. Again, flash technology, definitely resolutionary. Make sure to read more up on that in the future, but you can find all this on FARO's website, on our website, mossgeospatial.com. But again, thank you all, and we'll see you next month on the 13th.